Example 4, it says evaluate the function when x equals -2, 0, and 2. This is a piecewise defined function. What it means is you have a piece of one function, this one's showing for when x is less than 0, and you have another function for any time that x is greater than 0. So you're going to have to look at what your x value is. This part here is just a restriction that tells us when to use the equation, and whichever piece this fits in, then we're going to use the equation for that. So on the first one, we got x equals -2. Well, is -2 less than 0, or is it greater than or equal to 0? It's less than 0. So less than 0 is that top equation. So f of -2 is going to be equal to, let me back up here. So I'm going to use the top equation, f of x equals 3x minus 4. So we're looking for f of -2. So I'm going to build my skeleton. I'm going to plug in that -2, and we're going to work that out. So what's it give me? -6 minus 4, and so I get -10. So we know that the function evaluated when x is -2 is equal to -10. Okay, the next one is when x is 0. Well, is x less than 0, or is x greater than or equal to 0? Well, if it's x equals 0, it's equal to 0, so we're going to use the second equation. So we're going to use f of x is equal to the 3x plus 1. Alright, we're looking for f of 0. So 3x plus 1, plug in your 0, work this out. And so we find that f of 0 is equal to 1. And then it says also to find when x is 2. Well, is 2 less than 0, or is it greater than or equal to 0? It's greater than or equal to 0, so we're going to use the second equation there. So we're going to use when f of x is equal to 3x plus 1. We're going to plug in that 2. And we're going to work that out. So 6 plus 1. So we know that f of 2 is equal to 7.